So we're looking at the chain rule today, and the chain rule applies to functions of functions, or functions that are stuffed inside of other functions. And we actually looked at an example yesterday with the power rule where we had a function and that function was raised to an exponent, and we could take the derivative of that combined function. So this is a function f that is a function of u of x. Sometimes you will see this this other notation right here. So this is f of u of x. This is x composed with u of x. They mean the same thing. When you see this big open dot, it means that these functions are composed together, and you perform the function u on x. You take that value, and then you perform the function f on it. No different than right here, where you figure out what u of x is, and then you take that value and you put it into f and calculate what your y value is. Okay, the derivative is designed to find rates of change. And the chain rule, we don't do a formal proof of, but we do this kind of intuitive proof. We say, well, for a particular value of x, this inside function is changing 3 times as fast as x is changing for this one particular value at this one instant. So if x is increasing by 1, u is going to increase by 3. Now the outside function is changing 4 times as fast as u is. So if u increases by 1, f increases by 4. Okay, how fast is y changing with respect to x? So this inside variable, how fast is y changing? So every time x increases by 1, y increases by, pause the video now, think about your answer, and then resume the video. Okay, if you're like me, you didn't pause the video, but you might be thinking that y is changing with respect to x 12 times as fast as x. In other words, 3 times 4 times as fast as x. And you would be right, and that is basically the chain rule. Okay, so here it goes a little bit more formally, what the chain rule looks like when we get it on the round. So y is equal to y is equal to some function of x. Do I want to do it this way? dy du, du dx. Yeah, actually, let's stop this right now.